Right, so before we go on to any new stuff in algebra, I'd like to do a quick revision of everything we covered last day, right? So last day, we did a revision on algebra, and algebra uses letters to represent unknown numbers or unknown quantities, right? Algebra also uses the laws of directed numbers to either solve equations or to simplify expressions, right? And also much more. But we're focusing on using the laws of directed numbers to solve equations and to simplify expressions, right? Good. We did a recollection of multiplying algebraic terms, right? And we learned the coefficient is the number multiplied by the variable. The variable is the unknown, right? Coefficient, variable, we learn about those things, right? The addition and subtraction laws of directed numbers, right? Anybody would like to read the addition and subtraction laws, someone? One person? Anybody? Raise up the hand. Ooh, anybody brave today? Anybody want to like to just read the laws of addition and subtraction for directed numbers? Someone? Anybody? No? Nobody? Any person could unmute us, no man. Make sure you could unmute. Right. Go ahead. Anybody? One person raise a hand. Yes, no. Go ahead. Kyla?
Yes, sir.
Go ahead.
So for same signs, you add and keep the same sign, and then for different signs, you subtract and keep the bigger sign.
Okay. Fairly simple, right? And these laws, we only use them when we add in and subtracted. When we add in and subtracted, and we know this by now, right? We did this a lot last week. We did this in Form 1 as well, right? Right. Excellent with Kyla. We're going on again here now. Yes, no. All right. So here we have like terms. Like terms are terms with the same variable. Like terms are terms with the same variable. For example, x squared with x squared, xy with xy, ab with ab, right? For example, we see in different variables, right? They are unlike terms and we cannot do anything with them. We cannot simplify unlike terms, right? Nice. Moving along now, right? We did parts of an algebraic expression. We know there's a coefficient, a number multiplied by a variable, there's a variable, right? And there's a constant. A constant is a number by itself, right? For example, 1 is the constant here, 4 is the constant here, right? What is the coefficient of y? The coefficient of y is 2, right? So be familiar with them terms, coefficient, variable, and constant, right? You'll be using it a lot, right? Nice. We can't simplify like terms using a lot of directed numbers, and we did some examples, right? We did plenty of examples. Then now, solving equations, right? To solve equations, yes, students, we perform the inverse operation on the other side of the equation. We perform the inverse operation, right? And this is simple. Inverse meaning the opposite operation, right? Opposite operation, right? And let me see what we did here, right? So for example, x add 8 equal to 2. We move across the 8 here to solve for x, and we do the inverse of adding 8. The inverse of adding 8 is subtracting 8, right? And then we use the lowers here, same signs, adding to the same sign, right? And we get minus 10. Minus 10 is the answer for this equation. Next one here, we said x minus 7 equal to minus 3. The inverse of subtracting 7, the inverse of subtraction is addition. So the inverse of subtracting 7 is adding 7. So we're going to say minus 3 add 7. And here we use the different signs law, right? So right here we see the two laws being tested here, right? The same signs, which is add the two numbers together, right? 8 and 2 is 10, and I keep the sign. Negative here, I keep the negative in the answer. Different signs, however, different signs, we see different signs here. We're going to subtract, we're going to minus 7, take away 3 is 4, and we keep any sign with the bigger number, right? We keep any sign with the bigger number always, right? Nice. Moving along now. Moving along again, right? We want to look at the homework questions, right? So, right. So for the homework questions, students, the homework questions, we have to simplify some and we have to solve some, right? So let me go ahead and look at that now, right? So the simplification part, we're going to do that first. Number 1, we have to simplify what? 3a squared minus 10a squared minus 2xy minus 9xy, right? When we simplify, you must simplify only like terms. And you have to find out if they are like terms first. And look here, these are like terms, yes, because they're carrying the a squared. These are like terms here, yes, they're carrying the xy. So which law are we going to use now? That we need to decide. This one here is different signs law. We're going to subtract. So 10 take away 3 is 7 and keep the sign of the larger number, right? So that minus 7a squared. So we simplify 2a squared terms to be 1a squared term, right? And this one here, xy terms, we're going to use the same signs law. Add and keep the same sign, minus 11xy. You know that, right? Next one, part B now. Part B is what? Minus 6 plus 4x squared minus 1 minus 9x squared. Look at this here, students, right? I see a constant here and a constant here. So we're going to simplify the constants together. They are like terms, right? Nice. So to simplify this, we say same signs, add and keep the same sign. So we get here minus 7. Simple. Add them, keep the sign. Done. Next one. X squared with x squared. We see in different signs here, right? So we say 9 take away 4 is 5. X squared, and we keep the sign of the larger number, which is a negative. So negative 5x squared. That is the answer, right? That is the answer for this one here, for part B, right? Nice. Simple. Very simple. Very simple homework questions, right? All the homework questions on them is based on what we did already, right? Nice. Moving along here now, the part C of the homework, we have here minus 11ab plus 2ab. And we have minus 6c minus 7c, right? Which one are the like terms here? This first pair are like terms, and the second pair is also a pair like terms, right? So we're going to simplify them, right? But the first one, we're going to use the different signs law which we talked about last day, right? If you are still getting sure about different signs law, look back at the video and you're going to see different signs. Simple. Different signs, you find the difference, right? Difference is a subtract. 11 take away 2. 11 take away 2 because 11 carrying a negative, 2 carrying a positive. So you know it's different, right? Sure. 11 take away 2 is 9, right? I keep any sign with the bigger number, which is the minus 9ab. Right here we say same signs. Same signs is the sum, right? So we add in this 6 and 7 is 13, so that is minus 13c, right? So I'm gonna just write down that here as we was talking about it, right? Different signs. Different signs is to find the difference. And difference is the subtract. Right? And what? Same signs. Same signs is the sum. And sum is the add, right? Good. And you always keep the sign of the larger number, right? Yeah. Now we're good to go there. Nice. We have 2 more here to do. We have part D and part E, right? So I should fit it right here. So we have part D of the homework, which is minus 2x squared minus 3x squared minus 4x squared plus 11x squared. So look at this, a very big question. Take your time, do it in parts, right? Nice. So you can simplify the first pair of x squared terms, right? Only reason we can simplify it because they carry the same variable, right? X squared with x squared, right? Nice. So we say here what you want. Same sign, so we're going to sum them, right? Add them and keep the same sign. So this is 3 plus 2 is 5, right? Minus 5x squared, right? Next one, we have different signs. We're going to find the difference. So subtract 11 take away 4 is what? 7. So positive 7x squared, right? Nice. But if you look at this question again closely, this is our next pair like terms again, because it still have x squared here to simplify, right? So you're going to simplify these two here using the different signs law because I see the 5 carrying a minus and the 7 carrying a plus. So you're going to find the difference, which is 7 take away 5, 7 take away 5 is 2. So the answer is plus 2x squared, plus 2x squared, right? Nice. By the show of hands, all who got all correct so far. Number 1, well, part A, part B, part C, and part D. Kyla, excellent work, right? Look at hands going up. Excellent work, right? Anybody get in trouble with it? Don't worry, if you look back at the video, I see more than 10 hands going up here, right? It's excellent. Right, look back at the video, look back at the notes, and you could message me privately if you still get in trouble with this, right? Nice. But take note of this too as well on the side here. For those who get in trouble, different signs, they find the difference, same signs, they find the sum, right? And you're good to go. Nice. Last question here now in the homework is what? We have minus 3x squared minus 2xy plus 9 minus x squared minus 1. Right. Take your time with this. What I recommend you do here, students, is to rearrange it, right? Rearrange the terms on them. Also, you can fill out missing information. What is missing information here? This x squared here carrying a minus, but the coefficient here, it have no coefficient, so once you see that, it's understood to be 1. So it's 21, right? Nice. So let me rearrange. So I'm bringing this together with this. So I'm going to x squared group it with x squared. So minus 3x squared minus 1x squared. So I've grouped them together, right? I see a constant and a constant. I'm grouping them together. So I say plus 9 minus 1. The minus 2xy, it have no other xy term, but I still need to account for it. It still has to come in the answer, right? Minus 2xy. Good. So now we could go ahead and safely say we could simplify the first three terms, right? I see in same signs here, so we're going to sum, right? Same signs here, we're going to sum. So 3 plus 1, because we know the 1 was understood here. 3 plus 1 is 4, so this is minus 4x squared, right? Next one, I see in different signs, because the 9 carrying a positive, the 1 carrying a negative, different signs, we can find a difference, which is 9 take away 1 is 8. Keep the sign of the bigger one, right? And the minus 2xy, we just bring it back in the answer, right? Because these are unlike terms now, you cannot simplify unlike terms, you leave them as is. You leave them as is, right? Nice. So this is the end of simplification for the while, right? I will give you all a worksheet again to do some more homework questions, right? But what is more important than homework questions is understanding it and going through your notes before next class, right? Good. So the homework is just to reinforce everything we do, right? But sometimes if me again homework, put you back your examples and we did in class, put you back your laws and I try to learn what you could do and understand what you need to understand, right? Nice. Second section now, second set of homework, right? Which is solving, right? Solving. Remember, I send any notes for everybody, right? So the notes will be on the group chat as well as on the Google Classroom, right? Nice. So we have here number 2. The instructions is to solve the following equations, right? So we know when we solve it, right? X minus 11 equal to 5. We want to solve for x here in this equation here. So we do the inverse operation on the other side. Inverse operation, right? So the inverse of minus 11 is adding 11. So you're going to say, okay, x is equal to 5 add 11. 5 add 11, right? Simple. The right hand side do have a change. Only when you move an atom across this equal sign, then you change any sign, right? So you see what? Whatever is minus in is going to add in the next side. So x is equal to 16. X is equal to 16. All who got this one correct, let me see your hands, right? Once you get this correct, that means you understand the concept, right? Nice. I see hands going up. Excellent work, right? Keep up the work, right? Keep up the good work, students. Make sure do your homework, right? Get the habit. Write down all your notes if you miss anything, and get the habit to try your homework and right? Especially in the holidays here, right? Nice. Good. Next one. X add 7 equals to 15, right? The inverse of adding is subtracting. So you're going to subtract 7 on the other side. So x is equal to 15 take away 7, right? 15 take away 7, which is 8. So the answer for the second one is 8, right? Next one, we have part C here to do now, which is x minus 9 equals to minus 8, right? To solve for x here, students, we say, okay, you say I pass circle here and I show I carry this across, right? This will help me to show that, all right, this still moving across the equal sign, right? So from subtracting it to adding, minus 8 add 9. And what I could say here is different signs, right? Different signs is what again? To find the difference. Different signs is to find the difference. So difference is to take away. 9 take away 8 is 1. Keep the sign of the bigger number. So the answer here is 1 or positive 1, right? Same thing, right? Part D is what? X add 16 equal to minus 2. X add 16 equal to minus 2, right? We're going to do the inverse of adding 16. The inverse of adding 16 is taking away 16. So we say here x is equal to minus 2 take away 16, right? Minus 2 take away 16. And which law are we using here? Same signs or different signs? I'm calling somebody here, right? Which law are we going to use here, right? Abdul Aziz, you want to answer for this one? Which law are we using here?
Same sign law.
Same signs law, right? Which is what?
And the same sign.
Excellent. Sum them, right? So we say, all right, 16 and 2 is 18. So we have here negative 18. And that is the answer here, right? Done with that, right? Nice. Next one, the last one. Anybody want to help with the last one? We have part E over here, right? x minus 15 equal to minus 6. Anybody? Let me see anybody hands going up. Right, Jolene, go ahead, Jolene. Go ahead. You can unmute it. Okay. I don't think you're on mute, right? All right. Anybody else? Think your audio getting some trouble. Nobody?
Yes, sir.
All right. Go ahead. Go ahead, Adam.
Subtract and keep the bigger sign.
All right. Subtract and give the bigger sign. So you see x equal to minus 6. Add 15, right? Add 15. Now you can tell me now. Subtract and keep the bigger sign, right? So the inverse of taking away 15 is what? Add in 15. So you add 15 on the other side. And now you can say subtract and keep the bigger sign, right? 15 take away 6. 15 take away 6 is 9. And you keep the sign of the bigger number, which is positive, right? So positive 9. You might have put a positive because it's understood, right? And this is how we just do equations. Solve equations using the addition and subtraction laws, right? Nice. And this here is how we just simplify expressions using the addition and subtraction laws of directed numbers. Point to note, we could only simplify like terms, right? Like terms, right? Nice. So from this here now, we want to move on. We want to move on to the division and multiplication laws of directed numbers, right? Good. So I don't want you all tying up the addition and subtraction laws and the division and multiplication laws, right? The addition and subtraction laws is simple. These are summary of it right here, right? Different signs and same signs, right? Nice. So let me talk about the multiplication laws now, right? When we say multiplication laws, you need to know when to use these laws. When we use the multiplication laws, easy. When we multiply and when you see a multiplication sign, or sometimes when you see a brackets, we need to multiply, right? Nice. So this is the only time we use the multiplication law. If you look back here, nowhere I see a brackets, nowhere I see a multiplication sign. Nowhere I see a brackets, nowhere I see a multiplication sign. This here is now multiplication sign. These are x, right? These are x here, x squared here, right? Nice. So don't come and tell me, all right, watch. We using the multiplication laws here. No, you only use it when you see a multiplication sign or when we see brackets, right? Nice. So since we know when to use it now we're going to learn what the laws are. 4 simple laws. First law, a positive multiplied by a positive is a positive, right? Number 2, a negative multiplied by a negative is a positive. Number 3, a positive multiplied by a negative is a negative. And number 4, a negative multiplied by a positive is a negative, right? So these are the 4 laws we need to learn for multiplication. Point to note as well, this is the same laws for division, dividing directed numbers. These are the same laws, right? Nice. So let me look at some practice here now, right? So let's just say, okay, we have here minus 2 multiplied by minus 5. We see a multiplication here, right? So we say what? Negative multiplied by negative, negative multiplied by negative is positive. 5 multiplied by 2 is 10. 5 multiplied by 2 is 10. Simple, right? Nice. However, if it was this, minus 2 minus 5, I not seen any multiplication sign, I not seen any brackets. So guess what? You have to use the addition and subtraction laws. Let's go back to the addition and subtraction laws, right? Either same signs or different signs. Which one this was? This is different, same signs. Both carry negative, right? So same signs, we're going to find the sum. So you say, okay, 5 add 2 is 7, and we keep the sign. Add and keep the same sign, right? Minus 7, right? So you see the difference, right? Only when you see a multiplication sign, we could use this, or brackets. You could get away with them most, right? Next one. Minus 2x by 3y. Brackets here, we know we're going to multiply, right? 2 by 3 is 6. X multiplied by y is xy. Negative multiplied by positive. Positive is understood, right? Negative multiplied by positive is negative. Simple, right? Now go again. Minus 5a multiplied by 2b multiplied by minus 3a, right? We could do this in steps, in phases, right? We could do the first two first. Multiply the first two terms first, right? And then just see what you want after. So 5 by 2 is 10. A times B is AB. Minus by plus is minus, right? Minus by plus is minus, right? Yeah. So this is minus 10AB. Now we need to multiply this by minus 3A. Take your time. 10 3 is 30. Negative by negative is positive. A by A, AB by A. Well, A multiplied by A. Remember, something multiplied by itself is squared. So we say A squared B. So this is the answer here. 30 A squared B. Take your time when you're multiplying stuff like these, students. Take your time, right? This here requires us to do multiplication, so we do it in steps. The first two, and then we do the next one afterwards, right? Nice. So since we know how to multiply so good now, I think we should go on to the division. Did some examples of the division one now, right? Nice. So look at the division one here, right? Watch. Same laws for the multiplication, same laws for division. And we know when to divide. You see a division sign as a case may be, right? So minus 20 divided by minus 2. Minus 20 divided by minus 2. Negative divided by negative is the same as negative multiplied by negative. It's positive, right? 20 over 2 is 10, right? 20 over 2 is 10. Simple. Example again here, watch. Minus 45 x squared divided by let me say that's plus 9. 9x, right? Look here. To make this simpler, watch. X squared is x multiplied by x, right? X squared is x multiplied by x. And you're dividing that by our x term. So one of the x cancels off, right? So one of the x going to cancel off alone, right? 45 divided by 9 is 5. If you know your 9 times table, right? You can put a positive here. Negative divided by positive. Negative by positive. Negative divided by positive is negative. So the answer is negative. Negative 5x. Negative 5x, right? Because only one of the x cancels off there, right? Nice. And we have space for one more example here, right? We have space for one more example. And let's just say, okay, what? 3a squared divided by minus 12b, right? Minus 12b. Look here, students. Anything to cancel off here? Well, let me take your time. Let me use a different color here to highlight some stuff here, right? Very important stuff here, right? So positive is understood here, right? So let me get the sign first. The sign of this answer. Positive divided by negative is positive multiplied by negative. Same rule is negative, right? So the answer is going to be a negative, right? What we canceling off now? Watch. 3 into 3 is 1. 3 into 12 is 4. So you gain a 1 up here and you gain a 4 down here, right? A squared, nothing to cancel off with the a squared here. So you leave the answer as a squared here. Nothing to cancel off with the b here. So you leave the b down here, right? Nice. So let's take a time. This one here is a fractional term, a fractional algebraic term. Because why? Limited, right? And all the others, things cancel off nice and you to get one fixed answer. This one here, the b can cancel off with nothing on top here, the a squared can cancel off with nothing on here underneath, right? You just gonna really simplify a little bit was the 3 can break down to 1 and the 12 can break down to 4. Next way to write this answer is what? You can leave out the negative here. I mean, not the negative, sorry. You can leave out the 1 here because you know negative 1a squared. The 1 is understood, right? So you can say, okay, negative a squared over 4b. This and this is the exact same thing, right? Exact same thing, right? Nice. So all we did so far, we correct the homework, we did revision, right? Correct the homework and we explain back the laws involved, addition and subtraction laws. The addition and subtraction laws when we solving equations, because we're going back to me this when we had equations, right? And now this is new stuff with it, the multiplication laws, right? Most of you probably did it already. If not, take it down, take down the examples, and the multiplication and division laws is the same laws, right? So you can head up multiplication and division laws of directed numbers. Take these down and I'll give you some to practice and habit, right? Nice. Go ahead. Anybody have any questions so far? Anybody do understand anything? Feel free to let me know, right? Use the Zoom chat to comment, or you can unmute and let me know, right? Right, so we're going on now to do some practice questions now, right? Good. So when you're doing the practice questions, look back at the examples on them, right? And be mindful. Look at give a little trick question here. Trick question meaning this one here. does not require the use of the multiplication laws, right? This requires the use of the addition and subtraction laws, right? Same signs are keep the same sign, right? So be mindful of that. Only using multiplication laws and division laws when they see a multiplication sign and brackets, or when they need to when you need to multiply, right? Nice. So go on here now to the questions to try now. So go ahead and try these to the best of your ability. Look back, right, and try them, right? So go ahead. All right, students. So go ahead and try these 9 questions here. When you finish, if those of you who have my number could send a picture on WhatsApp of the answers, right? Nice. And when you finish, again, you could comment or you could raise your hand so I have an idea of how much you will finish. Keep your hand up when you finish. And yes, I'll give all you a little 5 minutes to do this, and then we're going on to do some solving, right? So this is simplifying using the multiplication and division laws, right? Nice. And feel free to look back, right? Look back at this until you learn it for homework, right? Nice. Good. Good. So the first one here, we're going to use the division laws for sure. Why? Because we see a division sign, right? Nice. We cancel off here. A cancel off A, right? 2 into 2, 1, 2 go into 12, 6 times, right? So the B remains, the B don't cancel off anything, so the answer is 6B. And the sign now, negative divided by negative is the same ruling for negative multiplied by negative, which is positive. So the answer is positive 6B, right? Or there's 6B. Next one, 15 by 3, 15 multiplied by 3 is 45, right? 45. A multiplied by x is AX, right? And minus multiplied by plus, negative multiplied by positive is negative, negative 45AX, right? Next one here now, right? Something wrong with this question because I'm not seeing a multiplication sign, I'm not seeing a division sign. So guess what? We cannot use any of these laws here in this question, right? What we're going to do here is apply the same signs law because I seem like terms. This is a A term and this is a A term. So I'm going to put this in a different color here, right? Nice. So you require to use the addition and subtraction laws here, students. So you're going to say what? Same signs, add and keep the same sign. Same signs, you're going to find the sum, right? You're going to find the sum. So we say, okay, we have here minus 12E, minus 12E, right? Minus 12E, 9, 10, 11, 12, I'll keep the same sign. Same sign, this one, I'll keep the same sign, right? Nice. Moving along now, division again here, simple. Y cancel off for the Y, 2 cancel off for 18 to gain 9. Positive divided by negative is negative, negative 9x, negative 9x is the answer here, right? Next one here is a little challenging, but we can pass. You can multiply these two first, right? 7 times 3 is 21. Minus by minus is plus, right? And you have the x there, right? So 3x times 7 is 21x, and negative by negative is positive. Now we're going to multiply that by minus 2x, right? 21 by 2 is 42. Negative by positive is negative. X times x is x squared. So the final answer is minus 42x squared, right? Next one, we have here is what? Same signs or different signs. We are not seeing no multiplication sign here. I'm not seeing no division sign here, right? So I know a positive comment here because this is understood to be positive, right? So what we're going to say here is because it's x terms, you can add them, subtract them using the addition and subtraction laws of directed numbers, which is different signs. Different signs is to find the difference. Different signs is to find the difference. Subtract and keep the bigger sign. 10 take away 2 is 8x, right? And we keep a negative there, right? Negative 8x. So these two are the two trick questions here, right? That's to show that you understand when we use it which flow, right? Nice. Continuing here now, simple. 9 into 90 is 10. Negative divided by positive is negative. A cubed over a now is a squared. You working for this? A cubed is what? A cubed is a by a over one of the a going to cancel off, right? So we get a by a is a squared, right? Simple. Next one, 4 2s are 8. AB by AB now. A by a is e squared. B by b is b squared. Positive by negative is negative. Positive by negative is negative. All right, last one here. Brackets, we're going to multiply. Brackets is the multiply. So we said 2 by 7 is 14 xy. Right? Nothing else to multiply here in the variables. Right? Over here it had to be squared because a by a is a squared, right? B by b is b squared. Nothing like that here, right? Negative times negative is positive. Positive 14xy. Right? And this here, once you understand how to do all the questions here, if you make a mistake in one or two, no problem. You're supposed to at least get at least 5 correct here, right? 5 or 6 correct here, right? Nice. And especially number 3 and number 6, pay attention to this and take note of it next week, right? This year, we need to apply the addition and subtraction laws, right? Does not need the multiplication and division laws, right? Nice. Good. So we have one more main thing to do before we close off class, right? And that is solving equations using the division and multiplication laws, right? Nice. So we're going to do that now. Right? So just like last week, we did simplification and then we did what? We did we applied the laws and then to solve equations. So we're going to see now how to solve equations using this, right? So I'm going to we're going to write back a little note, right? We're going to write back a little note, right? When we solve equations again, right? Right? So you say when solving equations, we perform the inverse operation on the other side of the equation. EQN is short for equation, right? Nice. Again, emphasize we perform the inverse operation, students, on the other side of the equation, right? Nice. And so far, we know the operation we learned so far, operation. We mastered this last class basically, right? The inverse of add is subtract, the inverse of subtract is add, right? So now the new thing we want to do here now, the inverse of multiply is divide, and the inverse of divide is multiply, right? Nice. Good. So let me show you all what I mean here, right? So let's go back to the homework question, right? The homework question is perfect. That's perfect to see this, right? Right. So we see the inverse of subtracting 11 is adding 11. The inverse of subtracting 9 is adding 9. The inverse of adding is subtracting as well, right? So we see that. And you see, I draw my arrows on them to show when you write the notes on it, you could use different colors in your notes. You could use different diagrams, arrows, anything that can help you understand, right? So when you revise it, it could be easier for you to understand. You quickly pick it up, right? Nice. So look at this here, right? So let me just say, okay, we have 2x equal to 10. 2x here means what? We need to understand what 2x means. 2x is 2 multiplied by x. So the inverse of multiplying by 2 is what? The inverse of multiplying by 2 is what? Divided by 2. So to solve for x here, students, we do the inverse of multiplying, which is dividing. So inverse of multiplying by 2 is divided by 2. So we say x is equal to 10 divided by 2. Simple. Right? 10 divided by 2. And 10 divided by 2 is 5. So x is equal to 5. Right? We're going again. Right? So create some space here so you could do as much examples as possible here, right? Next example, minus 3x equal to minus 15. Minus 3x is minus 3 multiplied by x. So the inverse of multiplying by minus 3 is divided by minus 3. So we say x is equal to minus 50 divided by minus 3. Right? Negative divided by negative is positive. 15 divided by 3 is 5. So we get 5 again here for the answer, right? Nice. We're going again now. Watch. 7x is equals to minus 14. 7x is equal to minus 14. The inverse of multiplying by 7 is divided by 7. So you say x is equal to minus 14 divided by 7. Here x is equal to the plus the plus is understood, right? Negative 2. Negative 2 is the solution to this equation, right? Nice. So let me look at some more difficult ones now, right? Okay. So we have here, let me say, okay, what? 16x or minus 16x is equal to 4. Minus 16x is equal to 4. What minus 16x literally means? It literally means minus 16 multiplied by x. Minus 16 times x. Minus 16 multiplied by x. So x is equal to the inverse of multiply by minus 16 is divided by minus 16. So we say x is equal to 4 divided by minus 16, right? But we know 4 is positive. So what we can say here is positive divided by negative is negative 0.41, 4 into 16 is 4. So negative 1/4. Negative 1 over 4 is the answer here. Follow that one, right? Nice. Now you do next one. Negative 8 is equal, and negative 8x is equal to 3. Negative 3, right? Negative 8x equal to negative 3. No problem here, students. Right? The inverse of multiplying by negative 8 is divided by negative 8. So we say negative 3 divided by negative 8. Negative 1 negative is positive. X is equal to 3/8. And 3/8 is a proper fraction. Right? 3 over 8. Just like a quarter is a proper fraction, right? Nice. Good. So let me go again now. We say what? 4x equals to minus 22. 4x equals minus 22. So what is the inverse of multiplying by 4x? Well, sorry, the inverse of multiplying by 4. To solve for x here, inverse of multiplying by 4 is divided by 4. So we say 22 divided by 4. So we say x is equal to, what to cancel off here? 2 into this is 2. 2 into this is 11. So we say minus 11 over 2. And I still am in proper fraction, so we could go again. So you could say the answer is negative divided by positive is negative, and this is 5.5, right? Negative 5.5. Right, negative 5.5. Right. So again, pay attention here. We're focusing on this piece of the law here, right? Good. And how it is knowing something is multiplied, it is attached, it is a coefficient to the term, right? It is different from x minus 3, right? X minus 3 is x, you take it away here, right? This one is multiplying when it's attached to the term, right? Next. Good. So I want you all take this down now, right? Take this down, and when you are finished, let me know, right? Right here. So look at these here, right? There are some equations to solve here quickly, right? So watch here. You see, okay. 3x equal to minus 19. And then we have what? X minus 3 equal to minus 19, right? Look at the two equations here. This one here, we're going to do the inverse of the multiplying by 3. So we're going to say, okay, x is equal to minus 19 divided by 3, right? And that is equal to what? 6 3s are 18, so that minus 6 and a third. Right, so you see the difference here. This one now, the old laws we're going to use, the addition and subtraction laws, the inverse of taking away 3 is adding 3. So minus 19 add 3. Different signs, we're going to find the difference and keep the bigger sign. So this is minus 16. So you see the difference in the two, right? Nice. So these are some examples for you to be thinking, right? Nice. So we have here what? Minus 6x equals to minus 4, right? Or let me make it easier. Minus 6x equals to minus 3, right? One misconception when students doing this here, they think, okay, bigger number they come on top always. No. What is being multiplied here is minus 6, right? Minus 6. So when we say minus 6 is being multiplied, we're going to divide by minus 6. We're going to divide by minus 6. So x is equal to minus 3 divided by minus 6, right? Minus 3 divided by minus 6. So x is equal to negative divided by negative is positive. 3 into 3, 1. 3 to 6, 2. So this is positive a half is the answer, right? Positive a half, right? Automatically, some people think the 6 coming on top and 3 coming underneath, and no, that is not always the case. Look at what operation has been done to the x. You do the inverse of that operation, right? Nice. And last example here for today's class, and I'm going to give you all the homework now, right? So let's say, okay, we have something like this. X plus 6 equals to minus 3, right? Good. Watch here. Right? We could even fix this to be something different. Watch. We could fix this to be something different, right? We could say, let's see here, we could say 6 plus x equal to minus 3, right? What is happening to the x here? The x is being added to the 6. Point to note, x add 6 is the same as 6 add x, right? Same thing as 2 plus 3 is 3 plus 2, right? Yeah. So is your choice now to rewrite it if you want, or you could understand from right here and say, okay, x is being added to 6, 6 is being added to x. So the inverse of adding 6, right? The inverse of adding 6 is subtracting 6. So we're going to solve this here. Now we're going to subtract 6 on the other side, right? So we say x is equal to minus 3, subtract 6, right? Which is equal to same signs, add and keep the same sign, which is minus 9, right? So look at these here. These are the number 1 and 3 requires the new law we learned, right? And number 2 and 4 was the old law, but they see a little twisted, right? So go ahead, take this down. I'm waiting for you all. I have some homework for you all to do, right? Right. Show hands all to finish up here. Nice. Right. Good bit of persons finish up here, right? Nice. So again, I'll send notes for you all. Make sure you read notes. You should read notes for next class, right? With the small exam next class. And also look at the homework here, all right? So the homework you have to simplify first, right? Take down the homework now, students. Alright, so do you see a testimony, a specific law? Be mindful of it what you're doing, right? And also I'm gonna put some revision questions here from what we did the first class, right? Right, students, that's the end of today's class. When you finish, you could leave, and the next class will be the next class will be next class will be next week, Tuesday. That's not. Just hold on 1 minute before you leave, right? Did I mention one more thing? Right? Next class will be next week, Tuesday, same time, right? Yeah, so that is it. So when you finish your exam, you can leave. I'll see you next week.